Welcome back. In front of us, we have a question that reads, calculate the energy necessary to change 3.6 kilograms of ice at 0 degrees Celsius into water at 60 degrees Celsius. Specific heat capacity of water is 4,200 joules per kilogram per Kelvin. Specific latent heat of fusion of water is 334,000 joules per kilogram. Solution. The problem that we are dealing with is we have ice at 0 degrees Celsius that is being converted to water at 60 degrees Celsius. So we will ask ourselves, how many stages will this transformation undergo from ice at 0 degrees Celsius to water at 60 degrees Celsius? If we should draw the heating curve, this is how we're going to have it. We will have temperature in degrees Celsius against time. We have ice that is initially at 0 degrees Celsius. So the ice at 0 degrees Celsius will be converted first to water at 0 degrees Celsius. So there is a phase change here. And then from here we'll have water at 0 degrees Celsius that will reach a temperature of 60 degrees. This is water. The first point is here where we have ice at 0 degrees Celsius. Then it becomes water here at 0 degrees Celsius. Then from water at 0 degrees Celsius, we move to water at 60 degrees Celsius. So basically, we're going to have two stages. This is 1, this is 2. Okay? Here is ice, here is water. Okay? So the first stage is about ice at 0 degrees being converted to water at 0 degrees Celsius. The second stage is water at 0 degrees being converted to water at 60 degrees Celsius. So let's first try to find the energy that is involved during the first stage. For the first stage, the first stage is about phase change. So if we want to know the quantity of heat, the formula that we have to use is Q is equal to the mass times the specific latent heat. In this case, it is the specific latent heat of fusion because we are dealing with a melting process here. So to be more specific, I will say Q1 because I'm referring to the first stage. This is equal to the mass of the ice times the specific latent heat of fusion. We will say Q1 is equal to the mass of the ice given in the question is 3.6 kilograms multiplied by the specific latent heat of fusion is given as 334,000 joules per kilogram. So Q1 is equal to 3.6 times 334,000. That is 1,202,400 joules. Moving on to the second stage, that is we're going to have water at 0 degrees Celsius being converted to water at 60 degrees Celsius. For the second stage, Since it involves a change in temperature, we're going to use Q is equal to MC delta theta, okay? Delta theta because there is a change of temperature from water at 0 degrees Celsius to water at 60 degrees Celsius. So to be more specific, I will say Q2 is equal to the mass of the water multiplied by the specific heat capacity of the water times the change in temperature. So Q2 is equal to the mass of the water will be the same as the mass of the ice because it's the ice that is turning into water. Multiply this by the specific heat capacity of water is 4,200. Multiply this by the change in temperature is final minus the initial. The final temperature is 60 minus the initial temperature is 0. So Q2 is equal to 3.6 times 4,200 times 60. Q2 will be equal to 3.6 times 4,200 times 60 is 907,200 joules. If we want to find the total energy, Q total, that will be Q1 plus Q2. Q1 is 1,202,400 plus Q2 is 907,200. So that will be 2,109,600 joules. Calculate the energy required to change 500 grams of ice at minus 20 degrees Celsius into steam at 100 degrees Celsius. Specific heat capacity of ice is 2,100 joules per kilogram per Kelvin. Specific heat capacity of water is 4,200 joules per kilogram per Kelvin. Specific latent heat of fusion of water is 334,000 joules per kilogram. Specific latent heat of vaporization of water is 2,260,000 joules per kilogram. Solution: we have ice that is initially at minus 20 degrees Celsius that is to be converted to steam at 100 degrees Celsius. So we will move on to draw the heating curve in order to know the stages of this transformation. So that is temperature in degrees Celsius against time. We have ice initially at minus 20 degrees Celsius. So how will it transform? Well, from ice at minus 20 degrees Celsius, it has to reach ice at 0 degrees Celsius. So that is ice at 0 degrees Celsius at this point here. From this point, we're going to have ice that is at 0 degrees Celsius being converted to water at 0 degrees Celsius. Okay, so here is where you have water at 0 degrees Celsius. So this region is a phase change. Ice initially at 0 degrees Celsius is being converted to water at 0 degrees Celsius. Then from this point, we will have water that is going to increase its temperature from 0 degrees Celsius to water at 100 degrees Celsius. So that is water at 100 degrees Celsius. So from water at 100 degrees Celsius, we will reach steam at 100 degrees Celsius. So that is also a phase change. There will be no change in temperature. Initially, we have ice here at minus 20 degrees Celsius. It has to reach ice at 0 degrees Celsius. So the whole of this is ice. That is from here to here. Now we have ice at 0 degrees Celsius here. That is to be converted to water at 0 degrees Celsius here. So for this region here, we will have the combination of ice and water. This region is where we have water at 0 degrees Celsius. It is to be converted first to water at 100 degrees Celsius. So the whole of this region is water. At this point, we have water at 100 degrees Celsius that needs to be converted to steam at 100 degrees Celsius at this point here. So at this point here, we have steam. So during a phase change, it means this region will have the combination of water and steam. We have just water at this point, so it is being converted gradually to steam, okay? That is called boiling. So which means we'll have water plus steam, okay, for this transformation here. We have 4 stages. This is stage 1, this is stage 2, this is stage 3, and this is stage 4. So we will now move on to calculate the individual energies involved in each stage. For the first stage, the first stage is the transformation of ice at minus 20 degrees Celsius to ice at 0 degrees Celsius. So since that involves change in temperature, we will say Q is equal to mc delta theta. But we are representing the first stage, so we will say Q1 is equal to the mass of the ice times the specific heat capacity of the ice times change in temperature. So that is Q1 is equal to the mass of the ice given in the question is 500 grams, okay? So that is the same as 0.5 kilograms. 0.5 times what is the specific heat capacity of ice. We will go to the question and identify it. The specific heat capacity of ice is 2100 joules per kilogram per Kelvin. 2100 times the change in temperature for the ice in stage 1 is going to be 0 minus 20, okay? The final temperature minus the initial temperature. So that is 0 minus 20. So we can say Q1 is equal to 0.5 times 2100 times 20. Q1 is equal to 21,000 joules. So moving on to the second stage, we have ice at 0 degrees Celsius here that is converted to water at 0 degrees Celsius. So this is a phase change. The energy that is involved in this will be the specific latent heat. Okay? Specifically, the specific latent heat of fusion. For the second stage, we're going to use the formula Q is equal to M times the specific latent heat of fusion. Because there is no change in temperature, we cannot use formula that involves delta theta. So we have to use the specific latent heat when you are dealing with phase change. So Q2 is equal to the mass of the ice times the specific latent heat of fusion. So Q2 is equal to the mass of the ice is 0.5 times the specific latent heat of fusion is given in the question as 334,000 joules per kilogram. So that is 334,000. Q2 is going to be equal to 167,000 joules. Moving on to the third stage. The third stage, we have water that is at 0 degrees Celsius becoming water at 100 degrees Celsius. So this involves a change in temperature. So we have to use formula that involves delta theta. For the third stage, we're going to use Q is equal to MC delta theta. So that is going to be Q3 is equal to M, which is going to be the mass of the water, times C will be the specific heat capacity of water multiplied by delta theta. So Q3 is equal to the mass of the water will be the same as the mass of the ice because it is the ice that is being melted or converted to water. So that is going to be 0.5 multiplied by the specific heat capacity of water is given in the question as 4,200 joules per kilogram per Kelvin. 4,200 multiplied by the change in temperature will be 100 minus 0, right? Is the final temperature minus the initial temperature for the third stage. So that is 100 minus 0. Q3 will be equal to 0.5 times 4,200 times 100. So Q3 is equal to 210,000 joules. Moving on to the fourth stage, we have water that is at 100 degrees Celsius here being converted to steam at 100 degrees Celsius. So this is a phase change. Water is converted to steam. So since there is no change in temperature, we have to use the specific latent heat, specifically the specific latent heat of vaporization. For the fourth stage, we're going to use Q is equal to MLV, that is the specific latent heat of vaporization. So we can say Q4 is equal to the mass of the water multiplied by the specific latent heat of vaporization of water. So Q4 is equal to the mass is 0.5 times the specific latent heat of vaporization is given in the question as 2,260,000 joules per kilogram. $2,260,000. So Q4 is equal to 0.5 times 2,260,000. That is 1,130,000 joules. So if we want to know the total energy, that is Q total, it is going to be equal to Q1 plus Q2 plus Q3 plus Q4. So what is Q1? Q1 is 21,000 joules plus what is Q2? Q2 is 167,000 joules plus what is Q3? Q3 is 210,000 joules plus Q4 is 1,130,000 joules. So if you sum that up, 21,000 plus 167,000 plus 210,000 plus 1,130,000, you get 1,528,000 joules.